Hello guys, welcome back to my YouTube channel. Today I am going to solve day 26 problem of this month on LeetCode. That is problem number 1289, minimum falling path sum 2. Okay, so actually LeetCode marks this question as hard level, but in reality I am going to say that this question is of easy or medium level. Okay, this question is not tough actually. Okay, so why I am saying this? See, this similar question, I think if you are if you guys are daily solving one question on this platform, then definitely you guys have encountered this problem in maybe few weeks back. Okay, so we have already solved this problem. Okay, minimum falling path sum. So this is of medium level. Okay, so both the problems are actually similar only, but this question is a little bit tougher than this today's question. Okay, so now why I'm saying this, let's try to understand. Okay, so here in this problem we have given one integer matrix n by n. Okay, this grid matrix, and we have to return the minimum sum of a falling path with non-zero shifts. Okay, so let's directly understand this problem with an example here. Okay, so here let me copy this example. So this is the example given to us. Alright, so here see, uh, this is my 0th row, this is my first row, and this is my second row. This is my 0th column, this is my first column, and this is my second column. Okay, so now at this position, okay, so at this position, if I am at this position, then what are the values that I am going to get? Okay, so I have to ignore this directly adjacent value. Okay, so this is directly adjacent column, right? For this column. Okay, for this column this is directly adjacent. Okay, so we have to ignore this. See here, a falling path with non-zero shift is a choice of exactly one element from each row of grid. Okay, is a choice of exactly one element from each row of grid such that no two elements chosen in adjacent rows are in same column. Okay, in adjacent rows they are not going to be in same column. Okay, so this is done. So how I am going to solve this problem? Okay, so for this position, okay, for this position I am going to find the minimum. Okay, what is the minimum value? I have to store one minimum value, so I have to ignore this. And from 2 and 3, what is my minimum? 2 and 3, 2 is minimum, so I am adding 6 here. Okay, so I am changing this to 6. Okay, so now this will become 6. Okay, for 5 I am going to ignore this, and from 1 and 3, which is minimum? 1 is minimum, so in 5 I am adding this one, so this will become 6. Okay, for this 6 I am ignoring this 3, and from these two I have to select one value which is minimum value among these two. So 1 is minimum, so here I am adding 7. Okay, this is done. So now new values are 6, 6, 7. Okay, so now when I reach at this position, then I have to ignore this 6, and from these two I have to find the minimum. So which is minimum from 7 and 6? 6 is minimum, so 7 plus 6 is nothing but 13. Okay, so new value is 13. For 8 I have to ignore this 5, and from 4 and 6, which is minimum, sorry, one thing here, one thing, for 7 we are comparing 6 and 7, right? For 8 we are going to compare these upper values. Okay, we have already removed this value, so let me delete it for confusion. Okay, so now, okay, so now for 8 we have to ignore this 6, and what is the minimum between 6 and 7? 6 is minimum, 8 plus 6 is nothing but 14. Okay, for 9 we have to ignore this 7, and from 6 and 6, which is minimum? 6 is minimum, so 9 plus 16 is 15. Okay, so once this is done, then after that we have to just go to the last row, and in last row we have to find the minimum element. Okay, what is the minimum value? 13 is the minimum value, so that is why we are returning just 13. Okay, this is very simple, right? Okay, so I hope that you guys are clear. Okay, and this is the minimum falling path sum 1 problem. Okay, so this is minimum level actually. So in this problem what we did last time, we are going to okay, let me explain this one as well. Okay, so actually in medium level problem, okay, we can just select if we are at this position, we can just select this column value, this column value, or this column value. Okay, so this is the only scenario. Okay, so for this, okay, so let's say 2 1 3. Okay, first row is 2 1 3. Okay, 2 1 and 3. So here here instead of 6 I can update values like this, which is if I go to the first row, okay, previous row, then 2, 6 plus 2 is 8, 6 plus 1 is 7. Okay, so I can search like this, 6 1 here, here and here. So actually this is out of bounds, so I don't need to compare it. So 2 and 1, which is minimum, 1 is minimum, so here this value becomes 7. For this 5 I can search in the like this, left diagonal, okay, upper and right diagonal, okay, this way. So which is minimum among all these? 1 is minimum, so I am going to update it as 6. 5 plus 1 6. And for this one, this way, and this way. So this here we are not going to get any value, okay, out of bound. So 1 and 3, which is minimum, 1 is minimum, so I am going to update this value as 5. Okay, this is done. Then after that we reach at this position, okay, at this position. So at this position when we reach, then for 7 and 6 I have to search like this, this arrow, and this arrow. 7 and 6, which is minimum, 6 is minimum, so 6 plus 7 is nothing but 13, right? And then when I reach at this position, so 7 6 5, which is minimum, 5 is minimum, 5 plus 8 13. And then I reach at this position, 6 and 5, which is minimum, 5 is minimum, 5 plus 9 14. Okay, so see here, 2 times I get this minimum value 13 and 13, right? So there are 2 paths, right? For this 13, what is the first path? 1 5 and 7. So what is the output? 5 plus 1 6 and 6 plus 7 13. Okay, so just we are right, this is one path, right? And after that, what is the next path? From 1 we go to this 5, and then we go to this 8, this 4, and then we go to this 8. Okay, so see here, 1 plus 4 5, so I am writing 5 here, and then 5 plus 8 is 13, so I am writing 13 here. So we have found 2 paths, right? So we have to just return here minimum as well. Okay, so this question is same. Okay, so I have explained you guys both the questions. Okay, minimum falling path sum and this minimum falling path sum too. Okay, so in minimum falling path, this is the logic. Okay, so we have to check, we have just ignore the top diagonal element. Okay, top adjacent to row. Okay, so you guys can refer to this code for solving problem 931. So I'm going to add the link in the description of my YouTube channel. Okay, and let's come to our today's problem. Okay, so here, so I hope that you guys are already clear what we are doing here. Okay, so now let's write the code is also going to be very simple for this one. First of all, let's calculate the length. Grid dot length. Okay, so I have calculated the length of my grid. Then after that, we have to one base condition. Let's say if n is equal to 1. Okay, if my n is equal to 1, then in that case, that simply means that there is only one element. Okay, that simply means we have to return this one. Okay, so directly I'm going to write a return grid 0 and 0. Okay, this is done. Okay, then after that we have to run one loop. So for int, okay, so now this is my example, right? So let me explain this with code as well, step by step. Okay, what I'm going to perform. Okay, so now I'm going to run one loop from int I is equal to 1 and I is less than n and I plus plus, and then for my j, int j is equal to 0, j is less than n and j plus plus. Okay, and then I'm going to update the values of my grid of I and j. Okay, so I have to update the value starting from this position, right? Starting from this position. Okay, so I'm going to update first value of this one. Okay, my I is 1. Okay, 0 1 2 0 1 and 2. Okay, so 1 and 0. So grid I1 and j loop j0. So I am going to update this value as like this, grid of I, comma j, existing value, and in this value I am going to add one helper. Okay, I'm going to call one helper method, and in this helper method I'm going to pass one grid, my I, my j value, and my let's say one min. Okay, so let's create one variable int min. Okay, int min is equal to integer dot max underscore value. Okay, so here, and just pass n. Okay, so I am hoping that this helper method is going to give me the value. Okay, so this helper method is going to ignore this value. Okay, because this is directly a parts, right, same column. Okay, both the values. So this helper method is going to ignore this value, and then this helper method is going to return the minimum of these two numbers. Okay, so I'm expecting my helper method to return a number like this. Okay, so once helper method is going to return a number to me like this, then after that I have to iterate over my last row. Right, here I am iterating over last row. So here I am taking one new min is equal to integer dot max underscore value, and then I have to iterate over each value one by one. Int value in my grid matrix, which row, last row, so I am going to write n minus 1. Okay, this is done. Then after that, inside this I am going to update my new min value as math dot min of new underscore min and value. Okay, and in the end I have to just return my new min. Okay, so this is done. Now let's write my helper method. Okay, so I hope that you guys are clear with this piece of code. Okay, so I am going to iterate starting from this position. Okay, I'm going to update this value first. So my helper method is going to ignore this because this is directly a part, same column, and from here it is going to give me minimum. Okay, so this is what my helper is going to do. So let's write the helper method. Okay, public, so it is going to give me some value, so int type. Okay, and int helper, and inside this pass my grid. Okay, pass grid, and then I am going to pass my int I and int j and int min and int n. Okay, then I have to run one loop for k is equal to 0, k less than n, k plus plus. Okay, so I am going to iterate over all the elements, and I have to ignore this as well, right? So here I am writing if my k is not equal to j. Okay, if my k is not equal to j, right? This is what I'm going to write, and here I am updating my min. Min is equal to math dot min and min between existing min, and my grid, in my grid k minus 1, that means simply means previous row, and the column k. Okay, so my min now is going to return the minimum from these two numbers and ignoring this one. Okay, and here once this is done, then we have to just return min here. Okay, that's it. Code is very simple, right? So now let's run it and see if there are any code issues. Yes, there are some code issues. So I haven't initialized int. Okay, anything else? Okay, out of bounds. So k is equal to 0. Why I am writing it like this? K is equal to 0. Here I should write like this now, I minus 1. Okay, k is my column, right? K is not equal to j. K is not equal to j. But here I is 1 now, so I am going to check from this position. So I minus 1. grid of I minus 1, and k is my column. Okay, and k only these two columns. Okay, ignoring this one, k is not equal to j. Okay, for this I'm going to ignore this and selecting the min from this number. For this I'm ignoring this 3 and selecting the min from these two numbers. Okay, so now let's run it. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. Okay, and for time complexity of this problem, so see here, there is one loop here and one more nested loop, and in helper method also we are calling one loop. Okay, so time complexity is going to be O of n cube. Okay, for this specific problem, but we can solve this problem using O of n cube, because the test case, because the input size is very small. Okay, so yes, we can solve this problem using the same approach. But if you guys have some better approach, then please feel free to paste that in comment section. Okay, so but this is a beginner friendly course, that is why I explained like this. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye.